Select the major product of the following reaction sequence. So we see here that we are starting with an unsubstituted benzene, and then we have a series of reactions. So what we want to do is we want to go through this one at a time, and we want to pay attention to what the transformation is, if it's adding something to the ring, and if it is, what sort of directing effect will that substituent have on the next reaction. So if we take a look at the first step, so we're reacting this with an acid chloride combined with aluminum trichloride. So this is a Friedel-crafts acylation reaction. So acylation because we're adding an acyl group. We're essentially going to add that ketone to the ring. So it's a Friedel-crafts acylation. And so that's going to add this 1, 2, 3 carbon atoms to the ring. And so Friedel-crafts acylation does not have the same sort of restrictions as an alkylation. We don't have to worry about rearrangements because the carbocation that we form, so what's going to happen in this first step is your chlorine reacts with the aluminum. So this is similar to what we saw in the Friedel-crafts alkylation. But here's what's going to be different. So when we generate a positive charge here, when this chlorine leaves, we generate a positive charge where it's resonance stabilized. So we don't have to worry about seeing rearrangements of a carbocation like we saw with Friedel-crafts alkylation. And that's because this carbocation is resonance stabilized. And so once you have that resonance stabilized carbocation, and I should make this bond linear actually because I've made a triple bond. So let me make sure to get this geometry correct. So we made a triple bond to oxygen, right? So it's going to make that sp in linear, so that looks a lot better. But regardless, the key point here is that this carbocation is not going to rearrange. So you're always going to be, when you're doing a Friedel-crafts acylation reaction, your new bond is always going to be directly to that carbonyl. So it makes drawing the product relatively easy. And so once we've got that carbonyl group on there, we want to think about what we're doing in the next step. And so we're mixing nitric acid and sulfuric acid. So HNO3, H2SO4. So this mixture of acids, definitely something you'd want to be careful if you were handling this in the lab, but these are conditions for nitration. So this is going to add an NO2 group to the ring. And so where that adds depends not on the nitro group, but on the substituent. So we'd hopefully recognize that what we have here is an electron withdrawing meta director. So what that means is that nitro group is going to add meta to the acyl group. So let's go ahead and draw that. So there's our acyl, and we have 2 meta positions because just 3 carbon atoms away from here. So either here or here, and it does not matter where you draw it, it's the same molecule. So I'm just going to put it down here. And so then we want to think about what we're doing in the next step. And so we've got hydrogenation conditions, hydrogen gas and palladium on carbon as the catalyst. So then the question is which one of these groups or both will it reduce? And so when you have an aromatic ketone, hydrogenation will reduce the aromatic ketone. It will also reduce the nitro group. So you will end up reducing both of these groups. And when you have that aromatic ketone with hydrogenation, you actually completely remove the carbonyl. So this sequence of acylation reduction is a nice way to get at a straight chained alkyl group that we wouldn't be able to access using alkylation. So that is a handy trick for adding a straight alkyl chain to do acylation and then later on to do reduction. And then the nitro group would be reduced to the amine. And so we want to take a look at where this is. We can see this in B. And one thing I want to point out that if we were trying to make this molecule from benzene, this is the only order that these groups could be added in. So even though the nitro group is also a meta director, remember that a nitro substituted benzene, so nitrobenzene, is too deactivated for Friedel-crafts. So you have to do the Friedel-crafts before you do the nitration. And if you want the meta directing, you want to do the reduction after you've installed the group, because while this is a meta director, the alkyl group is an orthopara director. So it's very specific in the order that we need to do these reactions.